Okay, so unfortunately I'm not here today, but luckily I'm here in spirit. There I am. You do need to write this down. We're going to be talking about ways to actually physically prepare solutions, because tomorrow we're going to start using some techniques, lab techniques, to actually make solutions ourselves of certain concentrations. So not just randomly making solutions, but of known concentrations. So one way that we can prepare solutions is, write this, okay, is from a solid. And this is what you guys were working on Friday with Miss Wiebel. There's lots of different ways that you can talk about concentrations. You can talk about percent concentrations, like mass, percent, mass, volume, percent, all of those more straightforward calculations. On Friday, you guys were talking about molar concentration, and you were introduced to this mathematical expression that allows you to calculate molar concentration. This is just short form for concentration, okay? Rather than memorizing a formula, it's a better idea to really kind of understand the units involved, and that's how we've been kind of doing our math all the way through, is through unit analysis. So as long as you recognize that molar concentration has units of moles per liter, you can get that by just dividing moles by liters. Okay? So that's all we're saying when we're saying C equals N over V. C is molar concentration. It has units of moles per liter. You can get to that by taking a molar value and dividing it by a volume in liters. Okay? And that will give you units of moles per liter. So just to start us off, let's just look at a fairly straightforward question about how to make a solution from a solid. So let's say you want to make a 0.50, pay attention to sig digs, that has 2 sig digs, mole per liter solution of copper 2 nitrate. Okay, and once you make it as a solution, the subscript will be AQ. Also note that this has to be a soluble ionic compound in order for you to be able to even make the solution in the first place. Okay, so we're going to use the solubility table again during this unit to talk about things like that, but that's the solution that I want to make. Now the other piece of information that I need is the volume, okay? So I would like to make a volume of, say, 250 mils. And again, the reason why I'm putting a dot after here is to allow you to recognize that this is 3 sig digs, okay? So that's what I want. Now do recognize this is the total volume of that solution. So all of your calculations have dealt with the total volume of the solution. So that is not just the volume of the solvent itself, it's the volume of the solute and the solvent mixed together. Okay, so you are using C equals N over V. So I don't mind if you use this formula. Okay, in this situation, I know the concentration, I know the volume that I'm aiming for. What I want to solve for is moles. Okay, so you can rearrange this formula. N equals C times V. Okay, but again, stop for a second and make sure that that makes sense with what you know about units. Your final answer will have units of moles. Okay, so what you're essentially solving for is the number of moles that you need to put into something called a volumetric flask that can contain 250 mils total. Okay, so what I mean by that is you're going to fill this volumetric flask up until a mark that says 250 mils. Okay, and once you fill it up, it will be exactly that total volume. Okay, so what you need to solve for is what mass of solid copper 2 nitrate you need to take and put in that bottom of the flask Add some water, allow that to dissolve. Look at how beautiful this picture is, okay? Fill the rest of the flask up to the mark, shake it up, okay? And then you will have a solution of the concentration that you are looking for, okay? But what you actually physically weigh out on a balance is, of course, is mass. So I want to know what mass of my copper 2 nitrate I need, but I can get moles first through my C equals N over V. Okay, so again, back to my calculation. So I'm back up here. Okay. Okay, so yeah, back up here to our calculation. If I take concentration, which has units of moles per liter, if I multiply it by volume in liters, then look at what happens to my units. Bottom cancels top, just like always, and I'm left with moles, which is what I want. But I need to make sure that I change the volume that I'm given in the question, which is given to me in mils, to a value in liters. Okay? So after all of that, here is my answer. Okay? I'm going to solve for moles. I'm going to take my concentration, which is 0.50 moles per liter. Show the units as you do your work. That will help you. I'm going to take my volume and convert it to liters. Make sure you recognize that there are 1,000 milliliters in 1 liter. Okay, so you can use conversion factor method to get that. I'm going off the screen, so I'm going to put my unit down there. So 250 mils is 0.250 liters. My bottom cancels, this should be on the top, okay, bottom cancels top. So 0.5 times 0.25, plug it into your calculator, which you probably don't really need to do. The answer is 0.125 moles, okay? So again, back to this beautiful diagram, that's the molar amount that I would need to take and put into my volumetric flask, fill up with water to a total of 250 mils, and that will give me the concentration that I'm looking for, okay? But I need to convert this to mass. So I'm going to quickly calculate the molar mass, because again I want to solve for mass, okay? So what I need to do is take my molar value, I'm thinking conversion factors here, okay? I'm going to multiply by the molar mass, which is grams per 1 mole. So I'm going to get this molar mass value separately by using my periodic table. Okay, so I've just calculated the molar mass. It's up here. 187.57 grams are equal to 1 mole. So 180, that's an 8. That is an 8. 7.57 grams are equal to 1 mole. Okay, so your mole unit cancels out. Plug that into your calculator. You should be doing this too. The mass then will be 23.44 grams. Okay, and then just as a little bit of a description, because you are physically going to be doing this in a lab activity probably tomorrow, what I would need to do is weigh or mass out 23.44 grams of my copper 2 nitrate, okay, and place it in a 250 ml volumetric flask. Fill to volume, okay, so fill to that 250 ml volume with water, okay, make sure it's dissolved, and you will have your 0.50 mole per liter solution that you were looking for. Yay! So that's one way to prepare solutions from the actual solid, getting a known concentration with a known volume. Okay, so the second way that we can prepare a solution is preparing a solution not from a solid, but from a more concentrated solution. Okay, so preparing a solution from a more concentrated solution. Another term for this is dilution. So you guys have definitely heard the terms concentrated and dilute before. What this reminds me of is buying that frozen juice from concentrate, and then you add water to make it drinkable because it's like thick and syrupy. So it's really, really concentrated, but you're adding water to get it to a concentration that you want. So they tell you how many cans of water to add. Okay, so the best way to do this, I think, is with an example. So here's the question that we're going to look at. And this is one right from your textbook. So if you want to look later, not right now, at page 320, I'm going to use the exact same question. So you can look at it afterwards if this is not enough. So the question is, your teacher, that's me, let's say you want to make 2 liters of a 0.10 mole per liter solution of sulfuric acid, H2SO4. You only have 0. You have 18. Let me just change that. There we go. You have an 18 mole per liter concentrated solution available. Okay, how are you going to do this? Okay, so you're not going from the solid, you're going from a more concentrated solution to make a dilution of that more concentrated solution. Okay, so you have this concentrated solution, you want to dilute it, so you're going to add water to it to get it to have a lower concentration, but not just any old random amount. Okay, you actually need to calculate it. So the first thing that I would maybe do if I were you, because let's kind of work through this, is here's your goal. Okay, my goal is I want a 0.10 mole per liter solution, and I want it to be 2 liters. Okay, what I can do first is solve for moles of sulfuric acid required to meet that goal. Okay, so you know that C equals N over V, N equals C times V. So N equals 0, and units will help you out. So avoid kind of memorizing where the C and the N and the V are in this. Think about what you're actually doing. If I take your concentration, which is moles per liter, multiplied by your volume in liters, look at how the units work out. Okay, so that makes me happy. Okay, and then I know I'm on the right track. So 0.10 times 2 is 0.20 moles. Okay, so think about what that means. This is the molar amount that I need in my new solution, and it's coming from here. So again, what you need is 0.20 moles in your new solution. Okay, this molar amount is coming from your concentrated solution. Okay, so think about again what you are doing. I know this picture is beautiful. Okay, you're going to be grabbing a 2-liter flask because I want again a 0.10 mole per liter solution, and I want 2 liters of it. So that is our goal. Okay, so I'm going to have a 2-liter volumetric flask. I'll show you what those look like tomorrow. They look kind of like this picture. Okay, and I want the concentration inside to be 0.10 mole per liter, and I have an 18 mole per liter solution. So what you essentially are solving for is the amount of this 18 mole per liter solution that you need to take and put in here, and then fill the rest up with water to 2 liters to get what it is you're looking for. That's the number that you just calculated, okay? You just calculated the molar amount that you need to have in your new solution, okay? This molar amount is coming from your 18 mole per liter solution, okay? So what you want to know is what volume of this 18 mole per liter solution you need to take out, okay, measure it out, take it out, put it in your new solution container to fill up to 2 liters with water, and that'll give you the concentration that you are looking for, okay? So let's do that. Again, we're going back to C equals N over V, okay? Volume then will be moles over concentration. Again, don't memorize. Think about the units, okay? You are rearranging this, so if you do have trouble rearranging to get from here to here, you got to come see me, okay? So the volume that I'm solving for is going to be the molar amount that I need to remove from my concentrated solution, and the concentration of that concentrated solution is 18 moles per liter. If you do a unit analysis, the molar amount will cancel out, and you'll be left with liters, which is what you want. So take a second, plug that into your calculator, okay? So 0.2 divided by 18 is, I got 0.0111. Recognize that that is a volume in liters, okay? So if you wanted to convert it to mils, you could do that, 11.1 milliliters, so just over 11 milliliters, sorry. And make sure you understand what that means, okay? That means if you take out 11 milliliters of this concentrated solution, it will contain 0.2 moles, okay? If you put that in a new container, you're putting in 0.2 moles, but you're adding a bunch of water to that 0.2 moles up to a total volume of 2 liters. When you do that, that will give you the concentration that you wanted, which is 0.1 moles per liter. The big idea here is, because I'm going to show you a shortcut for this in a second, but I really want to make sure you understand where it comes from. The moles that you end up with, so let's call them final, okay, in your final solution, is equal to, that's supposed to be an arrow, okay, don't be confused, is equal to the number of moles in your original, okay? So I'm taking out 0.2 moles from here and putting those 0.2 moles in here, okay? So the molar amounts are the same. The moles in that 11.1 mils are the same as the moles in your new 2 liter solution, okay? So a shortcut that we can use, I'm going to actually just write the formula, mathematical expression, mathematical formula up here, okay? This is what you should use whenever you're doing a question that involves dilution, okay? Now remember, again, C equals N over V, so N equals C times V, okay? And because the number of moles that we took out of the concentrated solution is equal to the number of moles that we put into the more dilute solution, what we're essentially saying is C times V equals C times V. If you have a hard time understanding this, for now, this is okay. I can help you with it tomorrow, but we are going to have practice just working with this formula today, okay? Now, the ones and twos here, 1 stands for initial, okay, and 2 stands for final. So again, what we're saying is the number of moles that we take out of the concentrated is going to be equal to the number of moles that we put into that dilution, okay, based on what we talked about on the previous slide. So let's do a question, okay, using this formula. So I want to make, let's say, a 0.50 moles per liter solution with a volume of, say, 2 liters, okay, from a 5 mole per liter solution. Okay. A hard part here sometimes is interpreting the question. Okay, what you want to make is your final. Okay, so this is what you are making. What you are starting with is your initial. Okay, so identify what you want to make. So I want to make this. That's my C2. Okay, I want to make it having this volume. So that's my V2. Okay, I'm making it from this concentrated solution. Okay, so this is my C1. So just analyzing our variables here, my unknown is V1. Okay, so you can figure that out just by looking at what's missing, but make sure, again, you know what it is you're solving for. You're solving for the volume of that initial concentrated solution that you need to take out of that concentrated solution, put in to a 2-liter flask, fill the rest up with water to get your dilute solution. And then the rest is just math. So again, make sure you understand how to rearrange mathematical expressions like this. V1 is going to be C2, V2 over V1, okay? Notice for a second, I've given you the volume here in liters. I could have given it to you in mils, okay? Oops, did you notice that I made a mistake? Why didn't anyone stop me? Down here, let me see if this eraser works. There we go, okay? I know some of you were yelling out, so thanks for noticing if you did. Is actually C1, okay? So the point that I was trying to make is, if I plugged in mils for V2 instead of liters, that would be okay. It would just give me a final answer that's also in mils. If I plug in liters for V2, I'll get a final answer that's in liters, okay? So here your volume units don't matter. They do if you're doing like C equals N over V, they do matter. But C1, V1 equals C2, V2, units for volume don't really matter as long as they match one another, okay? So V1 equals C2, V2 over C1. Now it's just a matter of plugging in. So I'm just going to squeeze it in on this one page here, okay? So that I don't need to go to, I want to wrap this thing up. So I've got a 0.5 mole per liter, okay, times my V2 is 2 liters, divided by my C1, which is 5 mole per liter. Okay, I'm going to get a number here. V1 is then going to be 0.20, should be 2 sig digs, liters, or 200 mils if you want to call it 200 mils. So again, make sure you understand what this number represents. It represents the volume of that concentrated solution. So if I take out 0.20 liters from that concentrated solution, put it into a 2-liter volumetric flask, fill the rest up with water, it will give me the 0.5 mole per liter solution that I'm looking for. Now, there are some textbook practice questions that you can work on. You should do that right now. I'm going to check them tomorrow, I promise. I will be here tomorrow, and if you have any questions about this stuff or anything that we've done, you can ask me tomorrow, definitely. Okay, see you then. And do your work, because I am trying to make this picture bigger so it's slightly more impressive. No, I can't do it. Ah! It's just tiny. It's a tiny head. I'm watching. I am watching. Do your work now.